As a data analyst, one of the most common SQL mistakes I see people making all the time is joining data without realizing that their join created a bunch of repeat data in some of their columns. And if you're unaware of that repeating data, this can cause problems in your dashboard or your analysis later on by inflating your numbers and skewing your results. Today I talk about how that happens, why it can be problematic, and what you can do about it. Stay tuned. Now, in the last video, you may have noticed that when I performed a join from the patients table to the immunizations table, I got a bunch of repeating rows. Why did that happen? Well, I'm about to explain, but if I get too technical, I just want you to take away one thing from this lesson. Depending on how you do a join, or multiple joins even, you can end up with more rows than what you started with. That's not always a bad thing, you just need to be aware of it. And make sure it doesn't inflate or skew your results if you're doing an aggregation like a count or a sum or so forth. That's the one thing I want you to take away from this lesson. So let's get into the weeds. So the first thing I want to do here is I'm going to show you what we get when we query the patients table. Notice that a single patient identification number doesn't show up more than once in this table. And if I scroll over here, I don't see any of the patient names showing up more than once. So each patient in this table is represented only one time. And if I run this filter to trim this down to just one patient, I only see one record for that one patient, Adelina Simonis. Now let's see what happens if I run a query and I ignore this where clause here against the immunizations table. Notice that I do see the same patient show up multiple times. The reason we see repeating information is because each patient has multiple vaccines throughout their lifetime. So these first two rows, for example, depict a patient that had two vaccinations on the same day, a flu vaccine and a herpes vaccine for this same patient. Now, if I were to uncomment out this filter here, and I run this, for the same patient that we looked at a second ago, Adelina Simonis, what we notice is that we've got 10 rows for this patient in the immunizations table. So from the year 1974 all the way through 1983, they received a seasonal flu vaccine every year. So there's 10 records here. Now I want you to notice these two tables side by side. On the left side, we just have that one patient's demographic information. On the right side, we have all the vaccines that they ever received. This is called a one-to-many relationship. For that one patient, they have 10 vaccines. So what do you think will happen if I join those two tables together? Well, I want you to first take note of how many rows we have in our patients table. We have 11,363. Once I use this query to join everything together, notice that my count jumps up to 165,493. And if I filter down to that one patient we've been looking at, Adelina Simonis, we can see that that patient information is repeating itself now. So why is this happening? Well, let's go back to this query on Adelina Simonis in the patients table. So this one-to-many relationship, what is happening is SQL is doing this join, and it's saying, all right, for this row, we need to pull in all the information about all these vaccinations that this patient received. And it can't just pick one, it has to pick all of them. There's a match to all of these because we're joining on the identification number, this ID number to this ID number. And because it sees a match here and 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 here, it's going to create a result set that looks at all of the combinations of that patient to the vaccine that they received on that specific date. So zero information is lost this way because SQL doesn't want to discard any data that might be important to us. So that's what's happening in this many-to-one relationship. We went from having 11,000 something records to 165,493 records when we joined that immunizations table and not look at just that one patient. SQL is creating new rows for us in order to preserve the information between the combination of the patient and the vaccine on the date that they received it on. And zero information is lost this way. There's other relationship cardinalities to be aware of, we only explored one-to-many. There's also many-to-one, one-to-one, and many-to-many. In a one-to-one relationship, each record in one table is related to one record at most in another table. It is a unique and exclusive connection between two tables. For example, a given patient can only have one medical record number, and a given medical record number can only represent one patient, although it is possible for some patients to not yet have a medical record number. If you do a join between two tables that represent a one-to-one relationship, you will not see extra rows created in the process. In a many-to-one relationship, this is just the reverse of a one-to-many relationship, where many rows in one table relate to, at most, one record in another table. In a many-to-one, no extra records are formed. So for example, a given immunization event belongs to one patient only. In summary, out of these three scenarios, the only one that will result in extra rows being created is the one-to-many relationships. So that's the one you got to look out for, and it's actually going to be the one that you're probably going to encounter the most. I haven't talked yet about many-to-many relationships. They're a little bit more complicated, and I'll be talking about them in another video. Now you might say, well, Josh, this is all fine and dandy, but how do I determine what the cardinality is between the two tables? Well, my favorite way is to use an entity relationship diagram, and that looks like this. I won't go into detail in this lesson about how to interpret one, but a good one will use what's called crow's feet notation to show you the exact relationship between the two tables. I've dropped a link down below for a good guide on this subject. If you don't have an ERD, here's what you can do instead. Now, before we go any further, I just want to let you know that I am working on a data analytics course that's designed to teach you everything you need to know to start applying for data analyst jobs in a hospital. This is my Clinical Analytics Accelerator course. It's going to teach you about all the SQL fundamentals. It's going to teach you Tableau and networking, all while exposing you to healthcare concepts and building that domain knowledge that you need to succeed. And you get a certificate at the end of it. It's still in development, but you can go to my website, datawizardry.academy, and sign up for the waiting list. Signing up for that mailing list will not only give you updates on my development of that course, but I'll also send you useful tips and tricks in building your knowledge and skills in data analytics in the healthcare space. So I'm going back to my patients table, but before I really start to dig into this, you should have a data dictionary at your organization somewhere, or maybe a data engineer who is knowledgeable about what the primary and foreign keys are. So you should consult with either of them first to figure out what your primary and foreign keys are for the table that you're planning to query on and join against. If neither of those options is feasible, you can kind of use an educated guess here. So if I were looking at this patients table, for example, I'm looking at this ID column. It stands to reason that this ID is going to identify the patients in this table. But just staring at this, I don't exactly know right off the bat if this is uniquely identifying every patient. Maybe this identification number here shows up again somewhere. So I need to determine the uniqueness of that. Now let's look at these other columns here. I see social security number, drivers and passport. I don't see anything else that could potentially be a candidate for the primary key. And the primary key not only has to uniquely identify every row, but it also cannot be null. And I do see that some patients don't have a passport number. Some patients don't have a driver's license number. Some of these patients may never have traveled before, or maybe they're not old enough to drive. So these are not good candidates for the primary key. The social security number, I do see that that is filled out most of the time. But not all patients are going to have a social security number, because you might have patients that are immigrating to the United States and don't have a social security number. So the ID number seems to be the only good candidate for the primary key. If I want to determine the uniqueness of this primary key, what I might do is I might write a statement like this, where I group on that primary key. I take the count, I order descending on the count. Then if I run this, oh, there's an error here. Forgot by. So I type in by, I run this, and you'll notice that because we have this in descending order, We should have seen like a 2 or a 3 up here if this wasn't truly unique, but we only see 1, indicating that this ID number that we suspect to be the primary key is unique. Seems like we have our primary key here. So when I run the immunizations table, I'm looking for the foreign key, and I see that we've got a patient number here. That seems a lot like this ID number in the patient's table, so I'm going to guess that that's the foreign key. But now that I know that this is my foreign key, what I need to do is I need to determine if this is unique or if there are multiple values associated with this foreign key. And I can see that these 2 rows here are already duplicates here. So what that means is this is not unique. But if I wanted to do this more systematically, I could use that same statement I did last time where I do group by, and this time it's patient. Let's say patient count order by count descending. I run that. And now we can definitely see that these identification numbers are not unique. It's actually getting repeated 37 times for this patient and 36 times for this patient. Because we know that ID is the primary key, that's automatically going to be the 1 in the relationship. This one over here, because it's not unique, it's going to be the many. So we have a one-to-many relationship here, and this is by far the most common relationship that you're going to see. You might be asking, well, Josh, why do I need to know this? Well, the reason you need to know this is because if you are not aware of your cardinality, if you're not aware if you have a one-to-many or a one-to-one, you might not be aware that you have repeating rows in your data set. And that can lead to overcounting of things. That could lead to the inflation of your counts or your sums or your averages. Let's take an example here. Let's say that I rerun my join and someone asked me to determine how many COVID patients do we have. Well, I might be tempted to look at this and say, well, I'll just write a where clause where I say that the description of the vaccine is COVID, and then I run that, and I say, yay, I've got 13,983 patients. Well, not so fast. That doesn't sound right because when we looked at our patients table, we only had around 11,000 patients. So does it make sense that we have more patients than the patients table? That seems a little fishy. And then, obviously you look at this and you see, oh, okay, so there are multiple patients showing up in this data set. We have Hetty Vaughn, Artie Cronin. They're showing up multiple times here, so it wouldn't be logical to just take the count here and say that we have close to 14,000 patients because we're seeing patient information showing up multiple times. So to take care of this problem, one strategy that we could use is using the distinct statement. So I have this column here that's uniquely identifying these rows. This patient here had the COVID shot, but they had it on 2 dates here. If we ignored this date, we would have duplicates here. So let me show you what I mean by that. If I remove this date column and I run this again, now we can see that these 2 columns are truly duplicates. If I run the distinct statement, that will eliminate my duplicates. So distinct ID, first, last, and description as the vaccine name. I run that, and now you can see my count goes down to 7,210, which seems more reasonable. There are actually multiple different strategies to deal with this issue, and we'll explore some of those methods in the next video, where we apply everything we've learned up to this point about SQL to build an immunizations query in SQL and plug that into a Tableau dashboard. And once you've built that dashboard, you can add it to your portfolio and show it to future employers. I cannot wait to show you that video. Thanks for watching, and I'll see you there.